Hi everyone, welcome back. This is the 38th video in our series on building a chess engine from scratch in the Java programming language. Our focus has been on the GUI, and this is actually the 10th GUI video. And it's important that we cover all of these topics thoroughly. I appreciate you guys being patient. My goal in this video is going to be to show you a couple of the important panels. You'll notice here what I have on my screen is the finished game, and some of the dimensions are different than what we've built so far in the versions you guys have built so far. I'm hoping in this video to have this what we see here on the left hand side known as the Taken Pieces panel, and on the right hand side the Move History panel. So that's going to be what we focus on next. So you'll notice if in this game I start making moves, we update the Move History panel, and when I take a move, then the pieces that are taken go into the Taken Pieces panel, and what you can also see is that it's sort of divided into a north and south section, right? So the pieces don't just intermingle. They, the pieces that were taken from black go on to black side, and the pieces that were taken on white go on white side. You might actually argue that, if white takes black's pieces, then black's pieces should be here. And we can modify that as we go forward. But this is how I've written it so far. So let's see if we can start to build this out a little bit. And let me come here. I'm going to close this project. This is the finished project. Here over in our development area, let's, right above tile panel, I want to create a class that's going to be used by the game table, which is going to be called MoveLog, and this is going to keep track of it. Basically, is just going to wrap all the moves that have been executed on the actual game board, right? On the game board that we're looking at in the GUI. So we're going to say private final list of moves, move log constructor, the default constructor, this.moves is equal to new array list. No big deal, nothing new there. Let's put some convenience methods on here. Public list of move, get moves, which is just going to return this.moves, and public void add move to the move log, final move, and this is going to say this.moves.add move, and public int size, which is going to return the number of elements in the move log, return this.moves.size, and public void clear. Really, we're just sort of wrapping all the elements in list. This.moves.clear, public remove move, return this.moves.remove an index. Oh, I'm sorry, no, move. And didn't like that. Incompatible types. Oh no, I'm sorry. That's supposed to return this.moves.remove. This one returns a boolean. We'll have another version, public remove that returns, that takes the index. Return this.moves.remove index. Okay. All these methods really basically just methods that are available on the list interface. And so now that we have a move log in our game, Now I want to create in my GUI area, I want to create a new class. It's going to be a new class and it's going to be called Taken Pieces Panel. Okay? So now let's talk about what this is going to be. So this is basically going to represent what I showed you where the pieces are taken. So on here we're going to say public. So this is going to be a Jpanel like everything else. It's just going to be a Jpanel. Why is it not like that? Public class Jpanel. Oh, duh. Extends. Okay. So let's do that. And I really hate doing this import all. I upgraded my IntelliJ recently, and it does the import Java x.swing.star. Maybe we'll come back and clean that up later, but it's unnecessary to import everything just to use Jpanel. So let's say public taken pieces panel. What we'll say is super new border layout. And set background, and you're going to give it a color. This is a color I chose, which is sort of like a beigeish color, if you will. Color.decode. You can use this or any other color you want. 0xFDF5E6. And maybe in a later video, I'll show you how I come to choose my colors and how you can actually decode, select a color based on this hexadecimal value. It's really just an RGB value encoded as hex. Set border, I should say, to panel border. And we're going to introduce a member field in here. Private static final panel border is equal to private static final etched border is equal to panel board is equal to new etched board border etched border dot raise. This is just fancy pants UI stuff. And this dot, and we're going to have I'm going to introduce two Jpanels inside of here. So let's say private final Jpanel north panel and private final Jpanel south panel. Okay, and this is really going to be the heart of this class. This dot north panel is equal to new Jpanel, and we're going to use a grid layout, new grid layout. If you guys don't know what a grid layout is, I would highly recommend that you look it up, but it's basically going to let us, well, I'll show you later, but 8 by 2, so 8 columns and 2 rows. So at most, in the taken pieces panel, you'll see 2 taken pieces on the same row, and 8 taken pieces show up in the in a given column. At most, you can ever take 16 pieces from a player. So that's why 8 by 2 is 16. Right? So the north panel is that, and this dot south panel is equal to new Jpanel, new grid layout, 8 by 2. I suppose you could be, if you were playing variations of chess, or if you did some sort of board setup where you allowed more pieces than 16 per side, then this would break down and you need to change it, but it works for now. This dot north panel dot set background is going to be the panel color, and I'll introduce this in a second. This dot south panel dot set background panel color again. And we're going to add this dot north panel to the current Jpanel, which is the taken pieces panel, and we're going to use the border layout dot north and add this dot south panel to border layout dot south. There it is. You can say this dot add. Right? Just to be explicit. And let's declare private static final color panel color is equal to color dot decode, another color that I want to choose. Actually, you know what I could do? I could simplify this. 0x FDF E6. I think that's right. Hey, I think that's right. 0x FDF E6 and let's say this. There we go. So now let's say set preferred size to taken pieces dimension. Trying to use member fields wherever I can here. So let's introduce private static final dimension taken pieces dimension is equal to new dimension, and let's make this a 40 by 80. This is arbitrary, obviously you can choose it, but you'll see what it looks like and if you're happy with it or not. There's going to really be one key method on here, on this panel class. There's going to be a method that we called redo, public void redo, and it's going to take as its argument a move log, final move log, move log. Okay, let's see if we can do the static import there. Okay, good. So the first thing that we're going to do whenever we redraw the taken pieces panel is we're going to remove everything from the current panel. So south panel dot remove all, just for simplicity. South panel dot remove all, and north panel dot remove all. Oops. Okay. Right. Okay. And then we're going to say final list of pieces, white taken pieces. We have to calculate this is equal to new array list. And final list of pieces, black taken pieces is equal to new array list. Right? Why isn't it all like that? Is piece not? Change signature of list to match piece. Huh. No. Oh, that's strange. Oh, AWT, that's really strange. I didn't want AWT list. Sometimes you get goofy imports. I wanted Java util list. There we go. Okay. For final for each of the moves, what we're going to say here is that for each of the moves in the move log, move log, right? For each of the moves in the, let's see, now I screwed everything else up. Let me get my, there we go. For each not applicable to type, oh, I gotta call get logs, get moves. There we go. If the move is an attack move, okay, then final, so what you're going to do is you're going to go through all the moves in the moves that have been made on the game, and if the move that you're looking at is an attack move, you're going to get the move that was taken from that attack move. So you're going to say taken piece is equal to move.getAttackedPiece. And if the taken piece get alliance, if the alliance of that piece is white, then you're going to say white taken pieces dot add taken piece, else if, and this is just out of paranoia taken piece, you can be sure it'll be black if it's not white, taken piece dot get piece alliance dot is black, then black taken pieces dot add taken piece, right? And then else, this is just, you know, you'll never reach this, but throw new runtime exception should not reach here. It means the piece is in black or white, right? That's it so far, right? So that's the heart of so all we've done so far is we've basically established in the game that we're looking at on the board what are the pieces that were taken that were white and the pieces that were taken that were black. And now we are going to we'll do a sort. Okay, so we're going to say, bear with me, collections dot sort, and we're going to say white pieces taken and white pieces taken, new comparator of piece. And here what we're doing is, so I'll explain this. We'll say ints.compare. We're comparing the, we're going to sort the pieces within the panel, within the north panel or the south panel by how strong they are. Okay, so all the pawns will be grouped together, then all the knights will be grouped together. It's just sort of visually nicer to look at. So we're going to say ints.compare p1 dot or o1 dot get piece value, and we haven't written this method yet, but we will. o2 dot get piece value. Okay, and we're going to do the exact same thing with black, right? So the only difference between, so we're going to copy this code, going to paste it, and instead do blacks taken pieces. Okay, so that's going to be nice. And the last step is simply to draw the taken pieces. Okay, so it's just going to be 2 for loops. So we'll say for final piece taken piece in white taken pieces. We'll do a try catch, final IO exception E, and we'll say final buffered image is equal to image IO dot read new file art. I think ours is in art pieces plain, so we'll say art pieces plain. Okay. Taken pieces, taken piece.get piece alliance dot toString dot substring of 0, 1, similar to what we've done in the past. Plus a space. Bear with me. Let me put some space here. Plus taken piece dot toString. Might need to revisit this. So let's assume we got that right. Probably didn't, but whatever. Final image icon is equal to new image icon of the image, assuming we got the path correct. Final JLabel image label is equal to new JLabel, and let me do that for now. I'll come back and revisit that. Let's say we got the label right, and we'll say this dot south panel dot add image label and e dot print stack trace, right? And so that's going to be for the white taken pieces. We're going to do pretty much the same thing for the black taken pieces. Anytime you have copy code, pasted code like this, it's better to put it in a method, and I might come back and clean that up and refactor it, but I do wanted to just sort of show this to you. Black taken pieces. All of the other logic, I believe, is going to be the same. Yeah. So now really the only two lines to sort out. There's three things that I want to sort out here. There's the get piece value method, and then there's the actual, getting the label correct with the scaled image. And then lastly, after the for loop, you want to call validate, and that should be it. So there's definitely a couple things I need to clean up here, but this is the class right here. This is the taken pieces panel class, and we're going to add this in to our table, and we'll see the dimensions of the table slightly change. And then we're going to use this similar approach that we just used here for the game history panel. It's going to be its own Jpanel class, okay? And we're going to flesh it out, and we're going to have a redo method, and that thing's going to be used from the table class, and we're going to basically redo it every time a move is made. Okay, so I'm going to stop here. In the next video, I'm going to go over this get pieces value method, and I'm going to clean this up to make sure that it works. So when we actually play the game, you can see the taken pieces panel. A couple of other things that I want to say is I promise. I know I keep saying that I will explain en passant shortly. The general algorithm is actually not hard. There's two parts to it. There's the move generation portion, right? And then there's the detection of en passant. So the idea is this. Let me see if I can give you guys the elevator pitch on how it's going to work. If you go to the pawn class, right, when we are generating the pawn's legal moves, one of the things that we want to be able to do is look for en passant, legal moves that correspond to an en passant attack. And in order to do that, we have to look at a property of the board, which is the en passant board. The en passant pawn. And the way that you detect the en passant pawn is that if the prior move was a pawn jump, then you can say that for certain that the en passant pawn is that jumped pawn, right? So what we would do is in move, when we do an execute of a pawn jump, whenever we execute a pawn jump, let me see if I can dig up pawn jump. Where's my pawn jump? Pawn jump. When we execute the pawn jump, what we're going to say is this pawn that's jumping is the en passant pawn for the board, right? For the board that we're about to build. Then, when we come to calculate the legal moves for the next board, for the pawns on the next board, right? Here we're going to be able to get that en passant pawn from the board and easily calculate whether we have an en passant attack or not. So it's really that simple. I promise I'm going to go over it. If you guys want to jump ahead and look at the code on my GitHub account to see that that's actually the case, you're welcome to do it. I think we're making good progress. I hope you guys are enjoying these videos. Please rate, comment, and subscribe, and we will see you next time. Thanks.